Hello, everybody. Thank you for being here. Welcome to our webinar. Today, we're going to be talking about one of my favorite topics, vegetable diseases and pests. And if you have joined us before, you might have realized that the music that played in the background was the same as last week. I apologize for that. I just realized in the middle of the song, and it's okay. It's just a song. So next we will have a different type of music. And just as a reminder, these are all Colorado artists, and we are kind of like getting to know each other and see from the background while people get on into the webinar. As a reminder, Colorado State University is an equal opportunity provider. So if you need any information or any accommodation, please feel free to follow our website or take a picture of the QR code. These are some webinar housekeeping details. This webinar is being recorded and we will post it on the planttalk.org/webinars. There you can view past webinars or register for the upcoming ones. Today we will use the Q&A feature for questions, so feel free to type them in there and we will do our best to answer them. We are past halfway of our What's Killing Your Plants webinar series. And as I mentioned before, we're talking about vegetable diseases and pests today. But next week, we'll talk about pesticide basics for the backyard gardener. And then we'll have two more on a squash box and three borders towards the end of May. So thank you if you have been coming to all of them. But if this is your first time, we're very happy that you are here as well. So we're going to go ahead and start, and I'm going to introduce our speakers today. And we have Sherry Schaefer, and she's the director and horticulture specialist in Pueblo County. She's going to be helping us today answer questions, as well as Lisa Mason, who's the extension entomologist and horticulture specialist in Arapahoe County. So they are both going to answer questions today in the background, so feel free to ask anything about vegetable diseases. The instructors today, or the presenters, going to be Cassie Anderson, and she's a horticulture specialist in Adams County, and she has over 10 years of experience working with extension and working with vegetables. So she is a person that knows everything about growing vegetables in Colorado, and she also managed the Grow and Give website, which we will talk later, but it's a great resource that is free for everybody here in Colorado. The second presenter is myself, and my name is Maria Ortiz Castro. I'm the Colorado Master Gardener State Education Specialist, and in my role, I have the pleasure to work with a lot of volunteers and the incoming apprentices to train them, as well as anybody that wants to take our Green School course or any of those webinars that we manage. My background is in plant pathology, and that's why this is one of my favorite topics. So we'll dive in and kind of explore vegetable plant diagnostics from the specific to Colorado. So we're gonna go ahead and start. And if this is your first time in these webinars or first time learning about extension, what is extension? Well, this is where the university meets the community. We are the outreach arm of Colorado State University, which is our land-grant institution, and we provide information that you can use every day. We offer unbiased research and evidence-based information. So, and this is crucial because it's kind of the research that is happening at the university by professors or grad students. We apply it and we give advice or information based on that research. Our offices have horticulture master gardeners, forage youth development, food safety or food preservation, as well as community development. So if you want to learn more, we invite you to visit our website, extension.colostate.edu, and visit your county office if you have any questions regarding our role in your county. So the outline for today, and I'm going to move this over here. We're going to go ahead and start with some general principles and integrated pest management, kind of like set the framework for what we're going to talk today. Then we'll move on to biotic issues, the who's who of fungi, bacteria, viruses, and bugs. And then we'll end it up and finish out with some abiotic issues that affect vegetables. So environmental disorders, nutritional problems, and those sorts of issues that you might encounter. Let's go ahead and start with our general principles. and integrated pest management. And as I said before, this is to lay the framework or kind of like everybody will be on the same page going forward into the presentation. So these are some key concepts. We'll talk about plant diagnostic process, symptoms and signs, disease triangle, and the difference between biotic and abiotic factors. And the first thing that we're going to talk about is the plant diagnostic process. And this is a process that we use to identify what's wrong with our plants. So we want to know, let's say you plant a tomato and it's doing very well. You bought it, let's say in the garden center, and you put it at the end, towards the end of May, and it's doing perfect. But mid to late season, it starts turning yellow, right? So this is where the plant diagnostic process will start kicking in and saying like, oh, what is wrong with my plant? So that's what we're gonna talk about. In identifying those problems, observation is key. So you are the one that is gonna observe in what is normal for your plant. Are those things that you are looking at, are those sudden or are they progressive? We will talk about signs and symptoms, and we will say like, is this a common problem that is happening in Colorado, or is this just something that I have never seen before? So observation is key in terms of the plant diagnostic process. The second thing about the plant diagnostic process that is important is to set those thresholds. So you are the one that is going to decide whether or not you should apply any management strategies. So is the problem cosmetic? So it's just a few leaves that turning brown. Is that a cosmetic problem? Or will you have market loss, or in the case of vegetable, yield loss? So will affect the disease or the pest that you're having? Will that affect your ability to get more tomatoes? Then probably your threshold should be lower than if you just have a plant that is just, oh, it's just some few leaves here and there that are affected. So that is important, setting this threshold. And then in terms of the management, please manage on a sliding scale. So it will depend on your pest and in your situation. So whether you have cultural, biological, or chemical or physical practices, manage them on a sliding scale. So you are the one that will make the decision which method apply and in which order to have. And this is because we want to have an integrated pest management approach. So CSU uses and supports healthy environments for all Colorado. So we use integrated pest management. So it's not just one strategy over the other one, but we use a combination of all of them. So cultural, mechanical, biological, and chemical practices. And we kind of like to use this, what we call the IPM pyramid, where the bottom part of the pyramid over here, we have the cultural practices. And as you go up into the pyramid, then there is an increased potential for environmental impact. So you can see that pesticides are at the top of the pyramid. So this should be your last resource, or this should be the last thing that you wanna start applying. Also because they are more expensive and the environmental risk is higher. So again, we want to encourage the combination and a holistic approach for all of them. We don't want to favor one over the other one, but what works best for your situation. And we will offer these based on the best available sign that to the moment and without any bias. So CSU Extension will not tell you apply biological agents over mechanical practices. It will be up to you to make that decision. So the second concept that we're going to talk today, and this is related also to the plant diagnostic process, is the way that we're going to know what's wrong with our plants. We're going to first identify symptoms. And symptoms is a plant's reaction or change, it could be a change as well, to the activities of the causal agent. So who is the causal agent? That could be a pathogen, or that could be a pest, so an insect or other arthropod. But the key here is that the symptoms are the plants telling you something. So you could have necrotic symptoms like we're observing here in the top part of the image on the left, like this corn leaf is showing those necrosis. So the death of the tissue, those brown spots are dead. Or you could also have here on these grapes, these brown dots or brown circular symptoms that you are seeing there. You could also have some discoloration like chlorosis. Again, in this corn leaf, you see this yellowing. This is the chlorosis. You're losing the green color. Or you could also have some overgrowth like these galls. This is on a tree, and it doesn't really apply to the vegetable, but you could see that this is something that is external, but is part of the plant. So it's not part of the insect itself, is part of the plant in this case. You could also have undergrowth, stunting, wilt, or blight symptoms. And a lot of people usually say, oh, I have blight. So blight will be the symptom that is the rapid death of the tissue. So when the plants are looking green and all of a sudden the next day they are black or they are dead, these are usually blight. But these are symptoms. They are on the plant. And symptoms could be localized, so they could be on just one part of the plant, like on the leaf or on these galls that are close to the roots, or they could be systemic, that is in the entire plant affecting. So you could have the wilt when the plants look like they need more water, that's a symptom. They are all wilted. Or mosaic when they are like in the entirety of the plant is by these discolorations, different patterns of greens, yellows. These are all systemic symptoms. And symptoms are very important because this is what you see, right? The plant is telling you that something is wrong with it. But the problem is that many different pathogens and many abiotic stresses can cause the same symptoms. So you cannot just rely on symptoms to identify what's wrong with them. And that's why we support ourselves with the signs. And signs is a macroscopic or microscopic structure or product of the pathogen. So you could have some resistant structure like this. These are microscopic. You need a microscope to see them. These are the Cleistotecia or the nematode. So these are, you need, again, a microscope to see them. Or you could have a macroscopic. So the teliospores in these three over here, it looks like an alien, but these are actually spores. And this is the evidence of the pathogen. So these are actually, well, I like to call it the fingerprints of the pathogen. So it's leaving some mark. And in terms of insects, you could have some frass, pieces. So all of those could be signs of them. Only biotics, so only things that are alive will have signs. So you cannot have a nutritional problem, for example, and have a sign because there is nothing alive in there. And these are some examples of signs. So you could have bacterial ooze. So it's kind of like this goo literally coming out of the plant or coming out of the leaf blade. You could have mycelia or spores, some reproductive structures like some mushrooms or these Cleistotecia that we were saying. These are like how they look on the leaf. The majority of the signs that we see here in Colorado are these spores, like the dry and fluffy appearance, like that are orange. These are some of those signs that we're seeing. So symptoms and signs will help us with the identification of those problems. And then the next step or the next type of term that we would like to say is the disease triangle. And this shows us the interactions between the pathogen, the susceptible host, so the plant, and the environment. So when you have these three things aligned, you will have disease. So let's say you have a pathogen and a susceptible host, so a plant that is susceptible, but you don't have a favorable environment, then you will be on this side, so you will not have disease. If the same happens that you have a susceptible host, but not but an environment and not a pathogen, then you will be on this green part, so you will not have disease. Only when these three are aligned is when you will have this disease. And this is just a visual representation on on these three components of the triangle. Coming back to the symptoms and signs, so symptoms will always be shown on the susceptible host, so on the plant, while signs will be referred to those, the pathogen. So if you see a sign, then you know that you are involved with a plant pathogen, and in this case, and then how do you manage it will help us understand this. So why I bring this concept of the disease triangle, we will use it later in the presentation, but whether you decide to tackle the host, the pathogen, or manipulate the environment, that will make your effective management better or not. So let's say if we're gonna manage the environment, let's say manage the overhead irrigation, for example, this will be crucial to manage or to prevent that. So these interactions are gonna help us in that way. So the last concept that I'm gonna talk today before we start on the actual examples is the difference between biotic and abiotic problems. So biotic, as I mentioned before, living, bio comes from life, Those are things that are alive. So pathogens that are parasitic, microorganisms, so you can not generally see them with the naked eye. You need something else to see them, like a magnifying glass, for example. You could have virus, bacteria, nematodes, fungi, oomyces, or phytoplasms. You could also have some pests like insects, other arthropods, or even mammals that feed or cause damage on the plants. These are some examples. You see these rabbits right now that are very active chewing on the grass right now, but once you have your vegetables, they will go for the fruit. Those are also all biotic agents or biotic problems. Then you could also have the abiotic, A, so non-living agents, that it could be the chemical damage or physical damage, like weather related. If the hail, for example, there is a hailstorm in the middle of August, that could be a biotic problem. Or you could have nutritional problems. This is an example over here on the corn after a windstorm. I don't know if this corn will recover since most of them are like broken off. Some of them, let me tell you, they did some of recover, but we lost in our trial more than 50% after that windstorm. You could also have some of that hail middle or late in the season that could also affect them, or some nutritional problems like this tomato blossom end rot that we will talk later in the presentation. So these are all these concepts that we will use, and these are some examples of them. So we're going to start on biotic issues, and we're going to say who's the host of the fungi, bacteria, viruses, and bugs. So we'll include them as well here. Some common plant diseases that we have here in Colorado, we will have some fungi, for example, powdery mildew or early blight. But keep in mind that we might have many other ones. We cannot potentially in 1 hour cover all of them, but we'll give you some examples. And the idea is that you are going to use this example to reference or to help you guide you through the basics of what's a fungi, what's the difference between a fungi and a bacteria to help you make the diagnosis in case you have some of the other ones. If you want to know more about these common diseases, you can click on this QR code and it will guide you through the Grow and Give website. We have short videos about them, and we will present this later again in the presentation. So this is only the first time that you will see it. Okay, so we're going to start with the fungi, then move on to bacteria, and then on to viruses. So fungal diseases of vegetables, and this is an example here on the raspberries. You can see that regular raspberry will look red, will be attached to the plant again, but then this one looks very moldy, and this is a fungi. So the spores, you see, these are the signs. The spores are literally coming out of the raspberry, and these spores are the ones that are going to be spread by the wind or the water and are going to pass to the other parts of the plant. Similar here in this corn plant, these are again the spores that are coming out of the plant, and it will help us spread. So there are several fungal symptoms that you could have. You could have some wilts, stem or crown and root rots, leaf spots or curling. That's an example, could be a symptom of fungal problems, galls, cankers, and damping off. And damping off is kind of like usually related to, in this case, to symptoms is on the roots. The roots look brown, and then if you make a cut on closer to that part of the plant, you will see that browning. That's the damping off. And then you could have some of those leaf spots, like over here on the top part of the screen or on the bottom. You could see they are spots. They don't know, or we don't know what type of pathogen it is, but these usually point to fungal symptoms. In terms of something that could help you identify them, you could have a hand lens or a microscope, either or, and the dry and fluffy appearance is what helps you identify that it might be a fungal problem. You can see this on this potato in the middle of the screen, or again, this is now a strawberry, but it's the same problem, botrytis, and is that green or gray on fungal spores. In terms of fungal characteristics, the damage is usually random. So it's not just all of them or just one or the other. It's usually random, and you will see distinct borders of lesions. And what I mean by that is that when you have it on the leaf, for example, leaf spots, there will be marginal areas where you have a distinct border between the dead part of the tissue and the live part of the tissue. And this distinct border of areas will be surrounded by a halo. So in this case, this halo is kind of like black, and then the pathogen is spreading through this red color. Or you could have this other one where the halo is yellow, and this usually points to those fungal problems. So you see the distinction between the dead and the live tissue is a characteristic of that fungal problems. And keep in mind that I say usually because you could have exceptions to the rule, but this is what is actually happening. And fungi can be spread by wind, water, soil, animals, and in animals, including us. That's why I include this person over here. If it's moving this equipment or their shoes through for example, through a field that is infected by a soil fungi, it could pass the spores in the soil or in the machinery, and then it will pass through the next one. So that's why it's important that we apply good sanitation practices when we're working in our garden. We could have equipment, plant material, or even insects can also spread these fungal pathogens. And how do they infect? Well, they could enter through the natural openings of the plants, so the lentil cells or the stomata. They could enter through wounds, so like holes into the plants, or they can even produce enzymes that will break down the cuticle of the plants and enter through that. The first example that we're going to bring about fungi problems is the powdery mildew. And you are going to see this is one of the most common questions that we get throughout the season. Powdery mildew is very common disease in Colorado, and it grows, or is very easy to identify because it grows on the surface, on the top part of the plant. So you can see over here, or in a close-up, this is early stages of the powdery mildew. And this is characteristic, the talc powdery type of symptom. And this kind of like white type of, it like talc powder was sprinkled on there. Some people say, oh, just wipe it off and clean the plants with like water or something. But this is actually coming from inside the plant. So just wiping the plant or the leaf out, it will not do really a lot of it. Powdery mildew pathogens are obligate parasites. And what I mean by that is that they need a living host to survive. So this is going to be crucial because these pathogens don't want to kill the plant entirely. They want to keep using the nutrients, not to the point that they are killing the plant. Some are host specific and other are generalist. What we mean by that is that the powdery mildew that affect cucurbits, for example, the zucchini plants in this case, is not the same one that affects tomato. So you could have zucchini and tomatoes close by, but the powdery mildew will be the same. It is very common in Colorado because it likes dry environments. It doesn't need free moisture, but it needs humidity. So the overhead irrigation, for example, and plants being close by will create that humid conditions, but not necessarily that free moisture in the environment. And the hosts or the plants that can be affected include beans, peppers, onions. The cucurbits are very susceptible, as well as tomato and some of potato solanaceous plants. And in terms of the plant damage, you could have distortion, premature leaf drop. In the worst case scenario, you have chronic stress. So the plant is showing symptoms that not doing well. So it could affect the yield in those worst case scenarios. So I'm going to bring back the disease triangle and kind of talk about the management. So you could tackle the pathogen. So in that case, you could remove the infected material to avoid the survival of the pathogen. And that's because I said that it's an obligate parasite. So if you remove that green tissue, sanitation will be crucial. So then you are removing those survival structures. You could also apply some fungicides like sulfur applications. Keep in mind, these can be temperature sensitive, and you need to buy a fungicide that is labeled or that you could use on food crops or on things that you are going to eat, right? So it has to be safe on that. You could also apply neem or horticultural oil. There are some studies that have shown that there is some effectiveness there early in the season. Or you could also apply potassium bicarbonate. For example, Cali Green is a fungicide that is labeled for that. Please don't apply sodium bicarbonate. A lot of people tell me, oh, I just apply baking soda and it helps. This sometimes is phytotoxic for the plants, and also baking soda is not a labeled fungicide. So even though it might have similar mode of action as the potassium bicarbonate, it could end up killing your plant, and then you don't know what effects might have, like eating those products or those tomatoes or potato from that matter. You could also tackle the host, so you can buy resistant varieties if they are available. But my personal favorite is to manipulate the environment. So you can improve air circulation, so don't have the plants too close to each other, avoid the overhead irrigation so that there is not that microclimate or that humid conditions, and avoid over-fertilization and overwatering. And again, this is coming back to the biology of the pathogen. Because your pathogen is an obligate parasite, if you are over-fertilizing, you are giving the plant more nutrients, so it will create more leaves. So it will just give the pathogen a reservoir to continue living and spreading. So over-fertilization and overwatering is going to be crucial to manage powder mildew. Second type of disease that we're going to bring today is early blight of tomato or potato, and this is caused by a fungi called Alternaria solanae. This is the scientific name, and it's very common here in tomato, potato, eggplant, sometimes on peppers, because we call it an opportunistic pathogen. So it takes the opportunity when the plants are stressed or nitrogen starving, and then it kind of infects at that point. It has the characteristic bullseye leaf symptom, like those concentric type of rings, and contrary to his name, it is present mid to late season when it is very dry and hot. So mid July, August is when we are actually seeing it. In terms of the early blight, the symptoms usually show up on the lower part of the plant and then work their way up. And this is because it's usually splashing the water, but also because it takes the opportunity, the lower leaves will have lower nitrogen than the younger ones. So that's why it's taking the opportunity on the leaves that are more stressed. It will survive in crop debris, so sanitation is crucial for this. And it normally doesn't affect fruit, but in potatoes, this is how it will show on the pictures over here. So it's very common, and it usually will be towards the end of the season. So in terms of management, I bring back again the disease triangle. If we want to tackle the pathogen, you could apply some fungicides such as sulfur. My disclaimer again, please pick up a fungicide that has been labeled and safe to use on food crops. You could also prune the diseased leaf, but please be careful that if you're pruning, you don't defoliate all the plants that you don't have any leaf to continue doing the photosynthesis. So it's not too much or not too little. You could also do the host or tackle the host with resistant varieties. So since the beginning, you are kind of like having less probability to have the disease. And the environment is really the most important method. So nitrogen management, because you don't want to have the plants stressed. So if you could maintain optimal levels of nitrogen, don't let the plants run out of at the end of the season. That will be crucial to manage early blight. Fertilize monthly. We usually recommend doing 3 fertilizations in terms of the tomato at planting, shortly after flowering, and when the fruit is setting, for you to have best results. Usually early blight, people might say, oh, it's just a cosmetic, and this is where the threshold affects. In the worst cases scenarios, it might affect yield. And so that's important when you're going to say, if it's middle to end of the season, do you really care about the yield or no? That depends on what decision you want to make. Okay, I'm going to stop here for questions if you have any. If not, I'll continue. Okay, I don't see any questions, so I will go ahead and move on to bacterial diseases of vegetables. And bacteria, contrary to fungi, are single-cell organisms. They reproduce by a process called binary fission. And most of them are rods, so they have this elongated shape. They have a bad odor that's very characteristic of bacteria, and they have a slimy or water soaked appearance. The good thing or bad thing about bacteria is that they will not survive once they are outside the host, once they are outside the plant. They survive for a short period of time, and they need to enter. They cannot enter a plant that is intact, so they need to enter either through a natural opening or through wounds. So that's why sometimes you will see bacterial problems after is very windy or there is sand, like a sandstorm, that will create wounds on the plants. So that's something to keep in mind. These are some of the symptoms. You could have some galls when they are close to the roots. They are usually bacterial problems. Soft rods, these are very common, for example, on onions. When this is like in the middle of the onion, the slimy type of appearance, the goo, literally. You could have overgrown scabs, cankers. The smell test is usually fairly effective for bacteria. So if it smells very bad, it's usually pointing towards that. And we have some pathogenicity tests that we could have on several host plants. This is one of the slides that I try to always bring up because it helps you identify if you have foliar lesions, what are some clues or keys for identifying between fungi or bacteria. So I told you that fungi, the symptoms are usually round, they are marginal, so they have different between dead and live tissue, and they are those concentric rings and the borders, right? You are going to check for sporulations. The difference with bacteria, so bacteria could have similar symptoms in the case of those spots, is that for bacteria, those symptoms are usually angular. They also have the yellow halo, but they do not cross the veins. That's usually going to be characteristic on bacteria. While fungi, excuse me, they will cross the veins like you're seeing in this diagram. So another characteristic is that these symptoms can turn papery and become into like holes, like get loss of the leaf, while for fungi, they usually don't happen. So this is usually characteristic. So if somebody brings a sample to the office and it's like a leaf spot, I put them against the light and see that yellow halo. And then the next thing that I look, is it crossing or is not crossing the veins on the leaf to kind of start from there if it's fungi or bacteria. Bacteria will have the ooze or the bacteria streaming. So you can cut, for example, in this example is part of the stem, and you see if this is coming out of the plant and into the solution, is usually that bacterial streaming. Or in worst case scenarios, you could cut, do a longitudinal cut, and you could see the ooze coming out, or this over here in the top is part of the screen. The management of bacterial diseases is similar, no matter the bacteria. The point is that it's very difficult to control because they spread very fast. There are some chemical options like copper-based products. Antibiotics are not very successful because they are very expensive and they have the risk or the potential risk to create some resistance. Since they reproduce very fast, they can change their genome very fast, so the antibiotics are usually not recommended. You could apply exclusion, so prevent the contamination of the seed, or buy certified disease-free seeds. My personal favorite to manage bacterial diseases is to manage the overhead irrigation. So that why we usually will recommend drip irrigation and try not to have the water coming into the leaf from the top part. You could plant resistant varieties if there are any available, or prevent the wounding like the blowing of the sand, the abrasions that we were talking before. You could also have eradication, crop rotation, pruning, cleaning of the tools is very important. If there are any insect vectors as well, we could have them. This is an example, or actually two examples of bacterial. We have the bacterial speck and bacterial spot of tomato. Bacterial speck is caused by Pseudomonas syringae, part of our tomato, and it has very similar symptoms. So these dots on the fruit or kind of these dots on the leaves. But this pathogen is a seed-borne bacteria, and it can also survive in crop residue. The difference is that it is favored by low temperatures and high moisture conditions. So If you transplant too early, you may have this because they are favored by low temperatures early in the season. That's different from the bacterial spot, which is Xanthomonas campestris pathovirus vesicatoria, and this survives in tomato plants. It might also survive in plant debris, but this is favored for higher temperatures, so 75, 85 Fahrenheit, and high precipitation. So this is mid to late season. So that's a difference between these two. The good part about it is that the management is the same. So you could tackle the pathogens with bactericides like coppers that we mentioned before. We could, in my opinion, tackle the host. So apply crop rotation. So don't plant the same plant or the same plant family for at least 2 years so that to decrease that inoculum. You could have seed treatments if you are planting safe seeds that you have from tomatoes, or produce disease-free transplants. So make sure that if you are buying them or you are producing them, they are disease-free. And in terms of tackling the environment, you could eliminate the volunteer host or potential weedy host, but avoiding those cold piles close to the production areas is going to be crucial because disease usually are going to be transferred through the transplants. So the last bacteria that we will talk today is the bacterial wilt of cucurbits. And this is a pathogen. It's called Erwinia trichophilia. It's very common on cucumber, cantaloupe, squash. Monkeys are highly susceptible. Somehow, watermelon hasn't been shown to being affected by this, but we don't know until we can see it. It is very widespread in the US, in Europe, in South Africa, and Japan, so you can see it. And the characteristics of this is that you see the drooping of the leaf. This is kind of similar to when you haven't watered your plants in the middle of the day, right? And then you go ahead and water them towards the end of the day so that the temperatures are lower. But the plants will not recover from this wilting. So instead, they will continue being wilted even though you have water. So this is a symptom that it might be a bacterial wilt of cucurbit. If you will cut the stems and see the bacterial ooze, that's definitely characteristic of this problem. Please don't, the fruit will go into the fruit and will eat. If you will open the fruit, it will have those lime rods and this smell appearance, so it's probably not good to eat it. The problem with the bacterial wilt of cucurbits is that it survives the winter mainly on the intestines of the stripe and spot cucumber beetles. And for me, this is why it's so hard to manage because you are counting or adding another factor to the problem, right? So you will need to manage these insects in order to manage the disease. And it's not so much that since they live on the intestines, so let's say this cucumber beetle is eating and is creating a wound. But as it's eating, it's also pooping, excuse me, my word there, but the feces is where the bacteria is happening. So because the feces are very close to that wound, that's how it's going to enter. So if you have cucumber beetle problems, you are likely or more likely to have these bacterial wilt of cucurbit problems as well. So management, as I mentioned, managing the cucumber beetle is probably the most important one. You could use insecticides early in the season. Exclude or regular scouting will be important as well. Resistant varieties, pick only fruit that's from healthy plants because the fruit will be affected by this bacterial wilt. And avoid moving the plant material from one field to another one if you have different, for example, different garden beds. So I'm going to go ahead and give it out to Cassie that will talk to you about viral diseases, but I don't see any questions. If you have any, please put them in the chat and I answer them.
Yeah. All right. Let's talk about those viruses. So there are some things to know when you're talking about pathogens that are viral in vegetables and in other plants. They are typically named by the first plant that the virus was found in. So you might have a tobacco mosaic virus, but you're seeing it in a cucumber. So the name does not necessarily tell you what plant the virus can affect because they often can cross different plant families. Viruses are most easily symptomatic based on symptoms of damage. You'll see mosaic or stippling, like in this picture here. The same virus can look completely different in a solanaceous plant, so a tomato or a pepper, as it will in a cucurbit, a cucumber or a melon or a squash. Generally, viruses are going to be obligate parasites. They only are going to survive in living tissue, which can be helpful in how we manage it. And virus is going to move systemically throughout the entire plant. So unlike that early blight that Mari was talking about, viruses are going to be in every part of the plant. You can't just pick off one particular part of the plant to manage viral issues. If you want to confirm that you have virus, then there's several different tests that you can do, including testing for the virus itself or serological tests. And there are many parts of the plant you can see symptoms. Sometimes the virus is only going to express in a certain part of the plant. It's not veggie, but the tulips that were really popular in the 1700s that caused tulipomania were the streaking effect of their petals was actually caused by a virus in the plant, which we desire, kind of a mosaic virus. But you can also see ring spots, you can see necrotic diseases, you can see opposite of chlorosis, where the veins of a plant will yellow or whiten, or various stippling and other odd growth. Viruses are going to spread in similar ways to bacteria and fungi, but they have their own little methods as well. If you have wounds in your plant, so if you are in a windy area, those little dust storms that we sometimes get in Colorado, you could have a wound on your plant that then would allow a virus to get entry. They can also persist in seeds. This is why good seed maintenance is really important. If you have because viruses are systemic to the plant, if you take a cutting and you propagate that, you will continue to have the virus in your new plant. Or if you graft a virus infected plant onto a healthy plant, both parts of the plant will then succumb to the virus. Viruses can also survive in that living tissue in weeds as other hosts and then come back to your vegetable plants the next season. And of course, insects can be vectors. They can transmit many different viruses. There are lots of different insects listed there that are likely to cause transmission issues, or that can move it from plant to plant. There are some things you can definitely do. Unfortunately, we don't have good chemical control for viruses. Mostly we're looking at our cultural practices. So staggering when you're planting it so that if there are weed hosts of the virus, that weed will die before your plant gets growing. Or exclusion, not letting the plant get into your area, making sure that you're buying good, clean seed or good, clean plants. If you do find a virus in your garden, making sure that you eradicate either weeds or the infected plant. We cannot treat the virus once it's in our plant, so roguing that plant out, getting it out of your landscape. Don't put it in your compost, just in case living tissues can persist. And then we can also use insecticides to manage those insects. And we can practice prevention. We can protect by covering our plants, having a physical barrier against those insect vectors, or using something like a reflective mulch, which can reduce insect feeding on plants because it confuses them. And then mixing up your crops, breaking up a row like in this picture where you've got a whole row of cucurbits, and making sure that you don't have the insects don't just go from plant to plant to plant, passing that viral infection down the line. All right, next slide. First example we're going to talk about is the tomato spotted wilt virus. This is definitely one that we see in Colorado fairly frequently in the summer. It is transmitted by an insect called a thrip, especially during seedling production. You often will see it as a stunted plant or distorted fruit. You'll see those kind of blaze or target marks on the fruit itself. The fruit is not going to be harmful for us, but it's definitely not going to be something that you want to eat. It's not going to have good flavor. And Tomato spotted wilt virus, although it's called tomato, can be found on pepper. It can be found on lettuce. You'll often see distortion of leaves because it is systemic. That virus is moving through the entire plant as the plant grows. So how do we manage it? We're going to look at this disease triangle again. If you can control those thrips during seedling production using insecticidal soaps or cultural practices, that's a great start. You could also make sure you're purchasing clean transplants. If you have any bedding plants that could be hosting the virus, make sure your seedlings are separate and inspect your seedlings for any symptoms before you plant them in your garden. Environmental, anytime, and if you see any symptoms of the virus in your garden, you want to destroy those plants, rogue them out, get them out and start fresh, or maybe say you're giving up on tomatoes for the season. All right. Our next one are the viral diseases of cucurbits. There are many different viruses that can affect squash and pumpkin in Colorado. We see cucumber mosaic virus at times, squash mosaic virus, watermelon mosaic virus, and zucchini yellows mosaic virus. If you want specific on each virus, you can go to that Grow and Give diseases page and get a little bit more detail. Most of these viruses are transmitted by aphids feeding on your crops, and the symptoms are going to be a little bit variable depending on which virus you've got and the time of infection. But they're going to delay and stunt the growth of the plants overall, and you're not going to have a tasty fruit at the end. So good to get it out. All right, so disease management on these guys. What are we going to do? In terms of the pathogen itself, you can try and control the insects. You can put on mineral oils or other insecticides to control the aphids. Not always the most practical way to go about it. You can plant resistant varieties. There are many cucurbits that have been bred to have higher levels of resistance to cucurbic viruses. That's not to say that they're immune, but they are going to be more resistant. And stagger your planting times. Try not to plant all of your cucurbits at exactly the same time, or perhaps have a late crop of a quicker to harvest cucurbit like a zucchini or something like that. And then, yes, you can put those reflective mulches in and control those weeds, particularly legumes, and anything else that you might suspect could be an alternate host. If you suspect a particular cucurbit virus, then you can go and do some research to find what those alternate hosts are for that particular viral issue. Okay, let's talk insect problems as well. I mentioned aphids already. There are so many types of aphids, so many different hosts. Some of them are very host specific, some of them are a little bit more generalist, but they're usually not going to kill a plant. They just are unpleasant for us. I know I wouldn't want to eat a Brussels sprout that looks like that picture. They are a soft-bodied bug that have a piercing, sucking mouth part. They rapidly increase in numbers because they are born pregnant. So if you scout and you find a couple, that's the time to eradicate them. Except I'm getting ahead of myself, because then the population can increase dramatically. All right. To figure out whether you have aphids, do some scouting of your landscape. Make sure you look on the undersides of the leaves or inside leaves on some of those brassica crops like cabbage or Brussels sprouts. Look for any leaves that are crinkly or a little bit cupped or deformed in shape. Look for honeydew, which is their excrement. They feed on the sugary phloem of the plants, and a lot of that sugar comes out after they have used it. And if possible, control that population early to prevent the population getting too large. Thankfully, aphids are not terribly challenging to control. You can hose them off with a strong jet blast of water. They're pretty weak bodies and they'll knock off and onto the ground quite easily. You can wait for the beneficial bugs. There are plenty of beneficial bugs that are going to come in and find the aphids to be an absolute feast. There are insecticidal soaps. Pyrethrins and neem oil can both be effective, as can be permethrin and bifenthrin. Make sure if you are going for pesticides that you read the label, that they are labeled for use on the crop that you're using and for the pests that you are trying to prevent. Row covers can be a really nice way as well, as can be trap crops. If you know that you want a good broccoli crop, maybe plant some Brussels sprouts, and the aphids are more likely to go onto the Brussels sprouts, and leave your broccolis alone. All right. Brassica caterpillars, I bunched these into one big group because management for them is fairly similar. But there are three main caterpillars that feed on our brassicas. So our cabbage, our cauliflower, our broccoli, the imported cabbage worm or cabbage butterfly, which is that top left, the cabbage looper, and the diamondback moth, which is on the right. These three are the most common ones we see on our brassicas, and all of them feed on the leaves. They can migrate, but we also see the pupa overwintering on crop debris, so good garden cleanup can be important. Weed crops that are related can also be sustaining in this population. We do have quite a few brassica weeds in Colorado, and thankfully control options are similar for all three. So once again, you can do that floating row cover, make sure it's tightly sealed. If you can prevent the adults from getting to the crop and laying their eggs on it, then you're not going to have the caterpillars feeding them. You can also hand pick. You can pick them off, drop them into soapy water. You can control with a BT product, which is Bacillus thuringiensis christaki. It's a relatively effective and fairly safe pesticide option. Effectively, they eat it and it destroys their digestive system, and they're out for the count. You can also decide to tolerate them. I don't always worry too much about them on my broccoli. Fairly often, if you cook your crop or your harvested plant, and then they'll float to the surface, and you can kind of skim them off. So it's all dependent on your tolerance level, like Mara was talking about at the beginning. Okay, cucumber beetles, both striped and spotted. We're seeing more of these in the northern part of Colorado. Adults are fairly small, quarter-inch long. They have yellow spots or stripes. Yellow or black, yeah, they're yellow and black with spots or stripes. They feed on a variety of plants, but we do see them especially on our cucurbits, on our beans and our corn. The adults are going to feed on fruits, stems, and leaves of flowers, particularly on those cucurbits and those beans, and the larvae are more likely to feed on corn. They can vector those bacterial wilts and some mosaic viruses as well. So they are problematic on several levels in our garden. Once again, for these ones, if you make sure that you don't leave any crop debris in your garden over winter, that can help reduce their populations. Also, providing heavy layers of mulch around your host plants will prevent the adults from laying their eggs in the soil. Floating row covers that are tightly sealed will prevent the beetle from getting it to your plant as long as you get it out early enough. Using drip irrigation so that the soil around the plants is dry will make it harder for the beetle to lay its eggs in the soil. And for a lot of beetles, one of my more off the wall recommendations can be to use a vacuum, like a little handheld vacuum, and vacuum up the beetles. Sometimes it's a little easier to do it that way than to try and pick them or collect them. Finally, you can delay your planting until they have laid their first series of eggs, which is often in July or so, or sorry, mid-June or so. Okay. Flea beetles are a little one that usually aren't super problematic, but they cause a lot of stress for gardeners early in the season. There are many different varieties of flea beetles. They feed on the leaves of the plants and create this shot hole damage that you can see in the picture here. Unless you have seedlings early on that get really impacted, they're not going to eat enough to cause serious dieback in your plants. But there are going to be several different cycles of them through the season. You're mostly going to see the damage in the earliest part of the season when the plants are small, though. Managing them, you can practice crop rotation. If you have a crop that just really gets hammered by them, maybe you only have that every few years. Make sure you're cleaning up crop debris and prepare your planting bed well. If you have some plants that you really want to plant, you can overplant your seedlings to spread the damage across them. And if you do have some seedlings that succumb, then you can thin out those and keep the ones that are looking healthier. Once again, with these beetles, you can use floating row covers and you can use vacuums. There are some pesticide options that you can use too if you're really suffering from their damage. Okay. And then squash bug. So squash bug had a little bit different life cycle than the cucumber beetles, but they also impact similar plants. They feed on the foliage. They like to suck out that sugary, the sugary phloem in the plant. They can often cause wilt in the plant. And they will overwinter as adults in leaf debris and in mulch. So management can help. Management of mulch and debris can help with that. They often lay their first set of eggs in June. Um, and if you can scout and get those first set of eggs out of the way, then that can help with management for sure. There are usually 2 generations in a year. All right. When you're scouting for squash bugs, you can check for the nymphs on the undersides of the leaves as well as for the eggs. Like in that former picture, you could see that the eggs are laid in between the veins of the leaves of the squash plant. For squash, mulch is going to provide cover and really good place for the squash bug to hang out. So not using mulch on the cucurbits can help manage with the squash bug. The opposite of the cucumber beetle, where mulch can help manage it. So it's kind of which one do you want to control more? For the squash bug, you can also use a newspaper or board trap. You put a piece of cardboard down near the base of the plant in the early season. They're going to hang out under there overnight. You can pull that board out and throw it away as a way to kind of capture some of those nymphs and adult insects. To control them, find those eggs, make sure you crush them. You can crush them pretty easily between your fingernails. If you're a little more squeamish, then you can use pesticides as well. Make sure you're spraying at the base of the plant because they will move up the base of the plant from hanging out on the ground overnight. All right.
Okay, so we're gonna end it up. I acknowledge that we have 2 minutes, but we're gonna do our best to not get you too far. If you need to leave, since this webinar is being recorded, feel free and then you can watch it at a later time. We're going to end it up with the abiotic issues. And as I mentioned in the beginning of the presentation, these are environmental disorders. These are things that are not alive. And because of that, usually corrective measures is what is going to help you manage them. So if you see a problem, you apply a corrective measures, and then you will usually see a benefit or fixing of the problem. You could have weather-related problems like temperatures when they are too high or too low, wind damage. We talk about those uh, uh, dust or damage, or flooding in not so common in Colorado, but sometimes we have them. Cultural problems that are related to water management, so that when it's drought, and this is not such a big problem with vegetables because you usually have to water them more regularly. But if you see uh, that the drooping of the leaf because you haven't watered, then that's usually related to the drought. You could have soil problems like related to the type or the pH, lack of or the excess of soil moisture if you overwater. Oxygen starvation will be also a problem if your soil is compacted. You could also have chemical damage like pesticide toxicity, and might be an issue if you are spraying, for example, some fungicide or pesticide to other plants, not necessarily to your vegetable, but the drift or the wind, they help the drift and they will have some chemical damage. Or you could have the most common one, nutritional problems, too much or too little or those nutrients, such as nitrogen, phosphorus, potassium, calcium. We are going to talk today, and this is probably the most common disease or, well, disorder in that case, in Colorado. Tomato blossom end rot is very common, and it used to look, or it looks like, is there is dead of the tissue on the fruit. It looks like black, like if it's rotted, but in reality, this is a problem with the calcium. There is lack of calcium to the fruit. And it's usually at the bottom, so where the blossom was. So the blossom, that's why it's called tomato blossom end rot. And it's caused mainly by irregular water. It's not so much that there is no calcium in the soil, is that because there is irregular water, either too much or too little, that is not being uptake by the fruit. And calcium is the concrete of the cell walls. So that's why the lack of it will cause these black spots or these kind of like rotted type of tissue. Too much nitrogen, similar to too much water, will cause the calcium to move into the leaves and not into the fruit, and that's why it's going to be a lack of calcium. So what are some solutions that you could have where regular watering from blossom set to the fruit is going to be crucial? And what I mean by regular watering is not that, oh, I'm going to apply water every day at the same time. It's not just that, but it's even water. So that's why drip irrigation will be important so that this water is evenly distributed so the roots can uptake it and distribute it equally into the plant. Mulch is going to be also helpful to manage the blossom end rot because it keeps the soil moisture even in the soil so that the plants can uptake the calcium. Avoid excess nitrogen. As I mentioned, too much nitrogen will move the calcium to the leaf where is the greatest growth and transpiration is taking place and not into the fruit. Planting warmer soils, that's why uh, we recommend transplanting the tomatoes or the peppers a little bit later in the season because the soil will be warmer. Avoid close cultivation and avoid high soluble salts because this will trap the calcium and it will like reduce their availability for the plants. It is important, and several garden centers sell these some products that say this calcium spray, or just spray the plants with calcium, spray the fruit. But this is actually not a good remedy because the calcium only moves through the vascular system. So it can only move inside the plant from the roots up to the fruit. So it's not well absorbed through the leaf. And some people have said, well, I apply a spray, calcium spray, and it fixed the problem, where it's actually that you apply the calcium spray, and if you have some irrigation or rain, that calcium spray went into the soil and went into the way that it's supposed to go through the vascular system, and that's why it helped. So it's up to you to buy it or not, but it's usually not a good remedy because the fruit doesn't transpire and it will not get that demand for calcium through there. So we could also have bolting in leafy vegetables. So bolting is when the plants form flowers prematurely, and this is mainly, for example, on the brassicas, are also on the leafies. When it's too hot, the plants are stressed. So the solution for this is to cover the plants from the excessive sun. So that's why some of those leafy vegetables like lettuce or the spinach, you could see some shade will help them from to prevent that bolting. You could also have the tip burn, and this is again on the leafy vegetables. This is the small spots of edges and kind of like turn brown or black. And this is the cause is the calcium deficiency. Again, this is the concrete for the cell walls. Is a water issue, rapid, and also related to the rapid growth. So what is the solution? It's water and fertilize regularly and evenly. So evenly watering is important for all those vegetables. The last one that we'll talk about is the yellow, green shoulder, and the sun scalp. The yellow and green shoulder is when you have the tops of the fruit, so it's not the bottom of the fruit, but the top of it is becoming yellow or green. And this is unfortunately irreversible, but you can eat the fruit because there is nothing alive in there. The cause is the high temperatures during the maturation. So above 86 degrees, it prevents that lycopene production, which is involved into the fruit, into the color red of the fruit. The solution is to avoid excess sun. And this is when it's going to be important if you have a problem with an abiotic issue, such as this yellow shoulder, and it also have early blight. If you are pruning all those leaves, you are defoliating, so you are not giving kind of like the shade for those plants. The last one that we'll talk is the sun scald. This is exposure to sunlight. We all know that Colorado gets over 300 days of sun, direct sun exposure. And since we are closer to the sun in the mountains, it is kind of important for that. This is mature green peppers are the most susceptible, and it usually happens on the side or on the top. And this is again, the lycopene is losing, so that cellular death. The fruit exposure is the cause to the sunlight, and the solution keep the fruit shaded or prevent diseases that cause defoliation. So that's why having, for example, early blight and defoliating those leaves it's gonna cause you probably a secondary problem, the sun scald on the fruit. These are some of the toolkits that we recommend if you are doing some scouting in your plant. So the handless or a magnifying glass, a camera, a pocket knife, a soil probe, shovel, notebook and pencil to take notes of what you are observing, plastic bags, insect collection jars if you see any of those insect problems, hand pruners, keep the records of the pests, and so that if you are going to apply rotation, then you know that next year you should change it for a different plant family. And of course, the extension office, books, and websites are also great sample or great in your toolkit. This is the Grow and Give website that we mentioned before. These are some extension resources, and you could see, on the QR code or in the website, we do have videos specific for each disease. So if you have a suspicion that you may have, for example, cucurbit mosaic virus, then you can go ahead and watch the video, and they are usually maximum 5 minutes, so you can learn about the management and how to work on it. The last thing that I'm going to say is that thank you for attending the webinar. We only went over 7 minutes. Please complete our survey. It's important for us to keep showing that these are relevant to you and relevant to everybody here in Colorado. So I'm going to go ahead and stop here. And if you have any question, I'll be happy to answer them. Okay, I don't see any questions in the Q&A feature, but again, take our survey. And we'll see you next week talking about pesticides. Have a good rest of your day. Bye, everybody.
Thank you, guys.
We will just remain here a little bit if we have some questions. Yes, we will post this on the Plant Talk website, and it will be the next probably Monday or Tuesday, but we will post it. And I'm gonna put the link in the for the Plant Talk.
You can also do a Google search for Plant Talk webinars, and it comes right up.
Yes.
Yeah, Heather, if you want to shoot me an email, we can learn a little bit more together.
Okay, perfect. So this is the link for the Plant Talk website, and thank you everybody for being here. Have a good rest of your day.
Thank you, guys.
Bye.